This video continues the lesson on basic differentiation. We're going to start with an example where we want to find the slope of the graph of f of x equals x to the fourth minus 3x at the point negative 1, 1. Well, we know slope comes from the derivative, so the first thing I want to do is find the derivative of my function. The derivative of x to the fourth is 4x cubed. And the derivative of negative 3x, well, the derivative of x is 1, so we just get negative 3. Then my slope would be the derivative evaluated at this x value of negative 1. So we substitute it into our derivative, and I get negative 4 minus 3 is negative 7. So if I were to draw a tangent line to this function at the point negative 1, 1, that tangent line would have a slope of negative 7. Okay, in this example, we're going to go a step further. We're going to write the equation of the tangent line. To do this, I need to know the equation of a line in point-slope form. And in order to write that equation of a line, I need a point, and I also need the slope. Well, we know the slope comes from the derivative, but what about the point? I'm only given this x value here. I need a y value to go with it. So to get the y value that goes with it, I plug a negative 3 into our original function, which is x squared, and I get the y value that goes with negative 3 is 9. So my x1, y1 will be negative 3, 9. So now that we have our point, we need to find the slope. So we're going to take the derivative of the function, and the derivative of x squared is 2x. The slope is the derivative evaluated at our x value of negative 3. And so I get a slope of negative 6. Now we're ready to plug into our equation. So I get y minus y1 is 9 equals negative 6 times x minus my x1 is negative 3. And so that is actually going to turn into a positive, that's x plus 3. And that would be the answer if I was asked for it in point-slope form. If I was asked to go a step further and put it in slope-intercept form, I would distribute the negative 6, and add 9 to both sides, and I would get y equals negative 6x minus 9. So both of these are equations of the line, and it just depends which way you are asked to give your answer, which one you choose to do. There are some other basic derivatives, and you just have to memorize them. Derivative of sine x is cosine x. The derivative of cosine x is negative sine x. And the derivative of e to the x is just e to the x. That's a really easy one. So let's do some derivatives using these. Okay, the constant multiple rule still applies to these functions. So if I want to do the derivative of y equals 2 sine x, then I keep the 2 out front, and the derivative of sine, we just saw, is cosine x. If I want to do the derivative of sine x over 5, well, that's the same thing as having a 1/5 times sine x, so we'll keep the 1/5 out front, and then the derivative of sine x is cosine x. Okay, also, if we have multiple terms involving these functions, we just differentiate each term separately. So the derivative of x plus cosine x, the derivative of x is 1. The derivative of cosine x is negative sine x. For example D, we have cosine x. The derivative of cosine is negative sine x. And pi over 3, that's just a number. So that's a constant multiple that stays out front. So we're going to keep this minus pi over 3 out front, and the derivative of sine is cosine x. Okay, for problem E, we have y equals 3 e to the x. That 3 is just a constant multiple, stays out front, and the derivative of e to the x is e to the x. For F, we're going to do each term separately. The derivative of x squared is 2x, and the derivative of e to the x is e to the x. Okay, now we have sine x minus e to the x. So the derivative of sine x is cosine x, and we're subtracting the derivative of e to the x, which is e to the x. In H, I want to rewrite this first term so I can see the power and power rule it. So that's going to be 2 times x to the negative 1/3 plus 3 cosine x. That's just a function rewritten, so I can use the power rule. Then the derivative of 2x to the negative 1/3 is 2 stays out front, negative 1/3 comes out, we get x to the negative 4/3, and then plus 3 times the derivative of cosine x is negative sine x. And we'll clean that up. We get negative 2/3 x to the negative 4/3. And we don't want to leave this negative here because we don't want it to look like subtraction from the 3. So we're going to rewrite that as negative 3 sine x. Okay, let's try another one. I'm going to rewrite this function as well so I can see the power. This is x to the 1/2 minus 5/2 e to the x. So for my derivative for the first term, 1/2 comes out front. I get x to the negative 1/2. And for the second term, negative 5/2 is constant multiple, just stays out front. Derivative of e to the x is e to the x. For problem J, I don't need to do any rewriting because my exponent has already been written as a negative exponent instead of a fraction. And I can just power rule it. A negative 4 comes out front. I get x to the negative 5. For the second term, negative 7 stays out front, and the derivative of sine is cosine.